Hello. In this video we will talk about DevOps in the Gauzy project and how it's deployed to the DigitalOcean, Civo, CoreWave and other clouds. Yeah. What we use there in the DevOps operations, how does it all work together, how it can be improved or changed for your own project, and so on. So, as you know already, I think we are using monorepo, and we are using GitHub actions that we execute that executed on each push to the relevant branch. So we basically have at the moment we use 3 branches. We have 3 fixed branches, right? We have develop branch, which is used for development. We have stage branch that use it for staging environment for deployments to staging environment, and we have also master branch that is used to deploy to production. And we have GitHub actions that executed depending on which branch there was a push of the code. Basically, how does deployment work is that we first build the Docker images. So we have this Docker build publish demo, Docker build publish prod, and Docker build publish stage. Those 3 GitHub actions. Let me just open one of them. So this is a demo one. Demo is basically like development environment, but it deploys to demo.gauzy.co. And you can see how does it work here. So basically any push to the develop branch, check out the code, right? Then it finds the Docker file and for the API, which is located in the let me show you. So the Docker files located in the deploy folder, API, for example, Docker file, yeah, or web app, and then in web app we also have another Docker file, right? And so what we do here is that we basically pull the repo, find the Docker file for the API, and build this Docker image, and push it to different registries. You can see here that we push it to GitHub registry. We push it also to the Docker Hub registry, official Docker registry, and then we push it to DigitalOcean private registry that only our account has access to this. And then we also push it to the CoreWave Cloud Docker registry. So essentially we're pushing the code to multiple registries, and then yeah, this is a places where we push the code. So we log in, for example, to DigitalOcean using DigitalOcean token, and then push to that registry in DigitalOcean here, yeah, and so on and so on. So we essentially push it, and then we do the same for the web app, right? So the web app has open Docker file, we build it and we push it. At this stage, after this action completed, we have basically result of this action will be Docker images pushed to different registries. For example, let's just see one of them, like here. You can see that you know, this is API, yeah, and the API was pushed, for example, to GitHub registry here, right? Prepare it, push it, and then it's done. And you can see the images in the packages here. So those are all our images in Docker. Docker images that are pushed to GitHub registry, right, which is a public one, and you can see here when it was last pushed, and the path to the image, and so on. Yeah, so this is the stage number 1. Then what is going on is that we have another GitHub Actions workflows that basically deploy what was just built into relevant cloud provider. For example, let's consider deployment to DigitalOcean. So you can see here the action called deploy to DigitalOcean demo. So basically it executed after building of Docker images is completed. Yeah, so we have conditional logic here that this workflow executes only after Docker images are built and published. And then you can see what's going on here is that we basically log in into DigitalOcean kind of command line. We initialize command line CLI for the DigitalOcean using some token, right? Log in into it, and then we push the changes to the Kubernetes cluster that runs in the DigitalOcean. So it's essentially, we're making deployment, right? We restarting deployment or do some changes if needed. Now, how does this work is that we have these files, Kubernetes manifests, right? They located in the deploy folder, Kubernetes folder, subfolder. Here we have all these manifests for different cloud providers. And this one actually what it's doing is it substitute some of the environment variables that are used in manifests with what we have defined below here, right? So because you can consider this manifest as a templates, yeah, that later on this manifest they using some of the environment variables that pass it into the Kubernetes pod, Kubernetes pod that runs, for example, web app, and so those are all environment variables that define it for this Kubernetes pod, and the values for them. So some of them we hard coded. And this is fine because this is all public tokens or whatever, not secured, yeah? We don't need to secure them, they're anyway available in the browser. But the idea is that some of them are passed also from the GitHub secrets, because it's just more easy for us to manage everything. And you can see that, you know, this is a template for the Kubernetes manifest, and as I mentioned, inside the GitHub action we substitute in this line we substitute some of the variables defined in the manifest with the real values of environment variables, which itself coming from secrets on GitHub, right? So somewhere in the GitHub we define its secret, for example, sentry traces sample rate, and then it passes it to this environment variable, which itself gets substituted in the manifest. So basically, as a result of this code, you get a manifest file with values that we need. And then what's going on, we just, we're restarting the Kubernetes deployment. And yeah, because it's using this manifest, so we get Kubernetes automatically updated all the information that needs to be updated. You can see here we applied those changes, right, to the manifest. Anyway, so as a result of this execution of this action, what's going on is that Kubernetes deployment gets updated with a wait, which instruct the pods to restart, right? And when the pod restart, it download the latest image for the latest Docker image that runs inside this pod. And so it's basically we just use always the latest build version. That is not optimal, of course. Yeah, later on we will switch to more tagged approach, more versioned strategy. But for now, for the last time, it serve us well. Yeah, we push changes. It builds the latest Docker image, and then this latest Docker image come to the basically downloaded by Kubernetes and executed in the Docker environment, in the Kubernetes environment. So that's what's going on. We have also additional pipelines or workflows running in GitHub that related to the building of desktop applications, which I don't want to touch at this moment in this video. But that is how we deploy. And then you can see that, for example, so the demo environment has very few environment variables here. But if you go to the, for example, let's say staging environment, you can see much more information passed to the, much more variables passed to the Docker to the Kubernetes manifest, and so later to the pods. And that's of course it's natural, because we need to define database connection strings, we need to define some other secrets that is used. For example, Wasabi use it for storage, cloud storage, like S3 compatible storage, and so we pass those secrets, and then Express, and then mail, SMTP configurations, and so on and so on. So there is much more environment variables that pass it in the stage and production environment. And yeah, and so those three are for cloud, for DigitalOcean Cloud. That's why we have DO here, DigitalOcean. Then we have the same for the Sivo Cloud. Yeah, so we have Sivo, we have using Sivo Cloud as well. And then it's basically mostly copy paste, right? So the same logic. There is a bit of more complexity involved in the Sivo or CoreWave clouds. The reason is that in those clouds we are not using load balancers that are available in the clouds. Instead we are using traffic load balancers, and because of that we need to generate like, you know, we need to use the certificates, yeah, for the domains that we kind of pass from the environment variables here into ingress. So basically we configure ingress certificates and we store them as a secrets in the Kubernetes. So you can see this additional code for the CoreWave cloud, and the same one for the Sivo cloud, where we basically just make sure that we define these secrets in the Kubernetes, and later on those secrets will be used in the Kubernetes manifest, yeah, to configure traffic SSL termination, TLS termination. So you can see it here. So once again, let's see Kubernetes manifest, for example, for CoreWave. So you can see here, so again, the same, more or less the same structure. Yeah, we define the service for API, for example, the ports, deployment. Here in the CoreWave case, we define a little bit more about node affinity, basically about which type of node we should run in Kubernetes. This is just implementation detail of CoreWave cluster. For example, for DigitalOcean, we are not doing it at the moment. We just use default. But the point is that yeah, and you can see that we're using a private registry in CoreWave where we deploy images, where we push images, and so we are using that private registry here. And then we pass environment variables. This is all common. This is where here we define what type, how much CPU and memory we need. This is all standard, more or less, for Kubernetes manifests. And so we do it for web app, we do it for API, and then if you scroll below here, you can see traffic, yeah, or networking in ingress configuration with the traffic. And you can see here that we just tell which secret to use to basically configure TLS termination, so SSL. And we do it for one time for API, one time for the web app. Yeah, that's a structure. And so this CV and CIVO, no, I mean the CV is for core wave and CIVO for CIVO. Yeah, and they have exactly the same structure. Yeah, so we do it exactly same things, doing exactly same things. We use traffic in both of them, and it's all working pretty well. Yeah, and so those are manifests. And you can also see that we actually also deploying platform to Fly.io. With the Fly.io, and we will deploy to more providers, right? And I want to talk a little bit about that. So essentially in the workflows, you can see there is one more for the Fly.io, right? So Fly.io, I mean this one, right? This project, this company, it allows you to quickly deploy your own projects into Fly.io, and we run there a small instance of. We are doing it just for demo, right? We are not using it in production, of course, but we are just trying to make sure that our platform can be easy deployed to any cloud environment. And so you can see here that we creating essentially 3 applications. One is database engine, which we created manually in Fly.io, and the others 2 are API and web app. And so you can see that the GitHub action for Fly.io, what it's doing is basically we checked Fly.io documentation, right? They have some actions that are available for us to run. And what's going on is that it uses some configuration files, like manifests for Fly.io. And you can see here that one is for web app, another one again for the API. And that's it. And it's basically reusing the same Docker files. You can see in the deploy folder, sorry, not in the deploy folder, in the fly.fly folder, you can see here this manifest, yeah, that essentially, this is specific to Fly.io, right? This is documented, all of this documented in Fly.io documentation. Pretty well, and it tells like you just need to submit the image of the Docker, and we will essentially run it inside Fly.io environment. You pass environment variables, similarly to how you do it with Kubernetes pods, and you configure some ports, some processes, blah blah blah, health checks. So it's pretty easy configuration actually. So we created this one for API and this one for web app. It's exactly similar to the other one. And you can see here we hard code again front end environment variables, but for the backend, I think yeah, we are just using it because it's a demo environment, so we just hard code some fake values, right? And that's it. And then again on the each push to our repo to the develop branch, we execute this GitHub action, and it basically deploys changes to Fly.io. And we pause machines, yeah, because they are not active. So it deploys, and then it's just pause temporary machines till someone access them or another deployment running. And so we did this for Fly.io. We'll do it for much more cloud providers. I mean, small cloud providers, yeah, not major ones. And it will be all the same way. There will be like some GitHub actions that deploy existing Docker images to specific cloud provider like Fly.io. Sometimes it could be that we will need to run some kind of infrastructure as a code solution that will create infrastructure in the cloud environment. Sometimes we just run some manifest like we do it here, and this manifest we predefine ourselves, yeah. So it depends on the strategy, like every small cloud provider have own standards on how it should be done. Yeah, so that's a short video about the current stage of deployments. Basically, you don't need, just to summarize, you don't need to build the Docker images yourself. They are built already as a part of our pipelines, workflows in GitHub. And then usually what is going on is that these Docker images deployed to different cloud providers, either via Kubernetes into Kubernetes clusters, which we actually created manually, right? So we kind of, we login into DigitalOcean, created Kubernetes cluster there, copied the token into environment variables, and then that's it. And sometimes we, for the FlyIO and other cloud providers, what we do, we create a separate manifests, because they're not running Kubernetes, yeah, they run some own infrastructure. So we create in separate manifest files. We describe there all the configurations that needs to be described, usually again using some pre-built public Docker images. And then that's it. And then we get a deployment to another cloud provider. So essentially for the DevOps purpose, you have this DevOps deploy folder. We also use Circle CI, but you can ignore this for now. Yeah, this is mostly, I think it's just some kind of pre-built things, and that's it. We also run integration tests before with Circle CI, so you can ignore this, but mostly DevOps done, deployments in DevOps done with this deploy folder, and also with GitHub folder, workflows. We are not deploying right now. You can ignore all those other additional software that you can see in Docker Compose. For example, in Docker Compose, you have Kube service running, Jitsu service running, Elasticsearch, Dejavu, Redis, and so on and so on. So at the moment, all of those things are not deployed from our public repo code, from our open source version into they are not deployed into Kubernetes clusters or to the FlyIO or anywhere else. So you can ignore all that. Yeah, what you need to know is that you need to deploy API, you need to deploy web app, and of course you need to create a database, right? Which you can create manually in cloud providers, like in DigitalOcean you have managed Postgres. In for example, Civo, you also have Postgres database engine running there. If it will be Amazon tomorrow, you will need to create RDS Amazon instance, same in Azure, GCP, and so on. Yeah, but essentially, any cloud provider will just need to deploy for now API, web app. Web app is just Node.js application that has Nginx inside, yeah, running inside the Docker. Yeah, and so that's, I think that's it. Pay attention to a lot of environment variables as well. As I told before, they define it in the GitHub secrets and pass it into the GitHub actions, which itself usually pass them to pods secrets, to pods environment variables in Kubernetes, or to FlyIO environment variables, and so on. Yeah, okay. Thank you for watching this. Goodbye.